Hello and welcome back to another Math 1040 Introductory Statistics lesson. This is lesson 10 about compound probability. We're going to take the ideas from the previous lesson and go a little bit deeper, understand a little bit more complex type of problems. In this first video, we're going to talk about something that's fairly important in the grand scheme of things called independent versus dependent events. Basically what you need to know is big picture, what's the difference? So let's get into that. First, a little notation. So we have this probability notation. The big P says probability, and inside the parentheses is we describe some kind of event. Now we have a new thing with this vertical character called a pipe character, and it means given. And so we would read something like this said as the probability of event B given that A already has happened. And this notation is fairly important. It helps us decide if something's independent or dependent. Events A and B are independent if the probability of B given A is just the probability of B. In other words, the outcome A doesn't affect outcome B at all. B doesn't have anything to do with A. This given that A happened doesn't change the probability. Some examples of that are flipping a coin. If I flip a coin and it lands on heads, even 5 times in a row, and it's a fair coin, the probability that the next flip is heads, given what happened before, is still the same. It's 1 out of 2. Another one is rolling dice. When I roll a die, it lands on a certain number, and I roll a second die. The first die has no impact on the second die. Yeah, so the 2 dice are independent. Dependent events, on the other hand, basically given that event A happened here, it has some effect on B. So we could calculate the probability of B by itself, and we calculate the probability of B given that some other event A happened, and if they're different, then B and A are dependent. The way this is written, the fact that A happened changed the probability of B, basically. So B depends on A. So let's get into some examples. I already told you this one, but you're rolling 2 6-sided dice with sides 1 through 6. Are the outcomes the first die lands on the number 1 and the second die lands on the number 6 independent or dependent? And just for simplicity, we'll let D with the subscript 1 represent the outcome of die 1 and D2 represent the outcome of die 2. And we can write it out like this. The probability that the first die lands on the 1 is just 1 out of 6. Well, let's say the second die has already landed on a 6. What's the probability the first die lands on a 1 given the second die already landed on a 6? It's still just 1 out of 6. So this second die landing on the number 6 has nothing to do with the first die landing on 1. So these two outcomes, first die lands on 1 and second die lands on 6, are independent. In fact, every outcome with pairs of dice, if we're considering the outcome of die 1 and die 2, it's always independent. Here's another one. Now we're doing cards. We're going to draw with replacement, and drawing with replacement is a sampling technique where we're going to draw something from the population, and we're actually going to put it back into the population before we do the next draw. So every time we draw from the population, it's a full population. This is not the normal way you play cards, but let's suppose we're drawing 2 cards with replacement, which means we're going to draw a card, look at it, write down what it was or remember it, put it back in the deck and reshuffle the cards and draw again. So in this scenario, are the events drawing an ace and drawing a 2 independent or dependent? So we can set up our little given. The probability of drawing an ace is just 4 out of 52. And the probability of drawing an ace, given that we drew a 2 already on the previous draw, is still 4 out of 52 because we put the 2 back and shuffled the deck. And so the probability is the same. Every single draw from this deck with replacement, we're drawing from the full population. And so nothing that happened before affects what happens next, or nothing that happens now depends on anything that happened before. So when drawing with replacement, these two outcomes are independent. In fact, that's always true. When drawing with replacement, each outcome is independent of the previous outcomes. So what we're looking at again is we found one probability, and we found one probability given the other thing that happened, and they're the same exact number. So this fact that this 2 already happened doesn't matter, doesn't change things when drawing with replacement. Now when drawing without replacement, things change. This is a sampling technique where we're going to draw something from the population and we're not going to put it back. This is the typical way to draw cards or draw people for a poll out of the population. This is the normal way. So when drawing 2 cards from a standard deck of cards without replacement, which again means we're going to draw the card and we're going to actually just keep it in our hand, are the events drawing an ace and drawing a 2 independent or dependent? So let's calculate the probability of one event. In this case, the probability to get an ace, and it's just 4 out of 52. And then we'll calculate the probability of that same event given the other event already happened. So the probability to draw an ace given that we already drew a 2, that 2 is in our hand. It's not in the deck anymore. The deck only has 51 cards left. There's still 4 aces out of 51, but because this probability of getting an ace and the probability of getting an ace given this other event drawing a 2 are different, they're dependent events. So the fact that this 2 happened changes things because our second draw is not from the population that we're drawing from is changed, basically. So here's a quick summary of what we just talked about. Events A and B are independent if the probability of one event given the other is just the same as the probability of that event. Doesn't matter if you can switch A and B around. The 2 probabilities are the same. That means this probability or this outcome doesn't affect this outcome at all. Outcome A does not affect the chance of B. Rolling dice, flipping coins, drawing with replacement are some examples. Events A and B are dependent, meaning the probability depends on the other if the probability of one given the other does not equal the probability of the one by itself. Meaning outcome A, when it happens, it has some effect on B, or we could say B depends on A. Drawing without replacement is a classic example of that. All right, see you in the next video.